Alright, 5.5, limits at infinity. Big thing with limits that approach negative infinity or infinity, we can use these to find asymptotes, okay? Horizontal asymptotes particularly. So y equals L is a horizontal asymptote if the limit as x approaches negative infinity of f of x equal to L, or limit as x approaches infinity of fx is equal to L. So one or the other happens is a horizontal asymptote. Sometimes you could have more than one horizontal asymptote depending on the function. The vast majority, if not all, of the functions we've pretty much worked with together, usually just one, if one at all. But we will be showing you some that have multiple. Furthermore, with the limits at infinity, this definition below is pretty much for, if you remember our rational functions, when we had a power higher in the denominator, remember that horizontal asymptote was 0. Well, the solution, whenever that happens with limits at infinity, is also 0. So, definition, if r is a positive rational number and c is any real number, then the limit as x approaches infinity of c over x to the power of r is 0. And also, if we just have x to the power of r and r is less than 0, then limit as x approaches negative infinity is also 0. Alright, for example, limit as x approaches infinity of 3 minus 2 over x cubed. Let's see if we can find this answer. So what I recommend, before adding or subtracting limits, separate this into two limits. Okay, so limit as x approaches infinity of 3 minus limit as x approaches infinity of 2 over x cubed. As we go to infinity, limit as x approaches infinity of 3, it's just going to be 3 the whole time. Alright, so your answer for that one's going to be 3. And then, based on your previous theorem, 2 over x cubed, the limit of that as x approaches infinity will be 0. So 3 minus 0 is 3. Alright, second example. Limit as x approaches infinity of 2x plus 3 divided by 5x minus 1. If I were to do each numerator and denominator individually, which you should try to evaluate first whenever you're doing any limit problem, you'll get it infinity on the top and infinity on the bottom. So we can't solve that yet. Okay, but what we can do to help us is if we divide both the numerator and the denominator by x. And what does that do? Well, if we do that, and we divide each of them individually by x, we will get, I don't want an arrow, I want equal sign. We'll get 2 plus 3 over x over 5 minus 1 over x. Okay, and now what? Well, just like in the previous problem, except we have a numerator and denominator this time, we are going to do the limits individually. So we are finding limit as x approaches infinity of 2 plus limit as x approaches infinity of 3 over x divided by the limit as x approaches infinity of 5 minus limit as x approaches infinity of 1 over x. And then we can solve these each individually, right? Because as you go to infinity here, it's going to be 2 the whole time, right? Your output will always be 2 as you go to infinity. That second one, you're going to be adding 0, right? Because of our previous theorem. Below here, 5 minus 0, same rationale as the numerator. And then we add them. And you get 2 over 5 rather, as a solution. As I alluded to in the beginning of the video, I talked about how there could potentially be more than one horizontal asymptote. And this function right here is an example one of those moments, okay? So I have the same function, x over the square root of x squared minus x, for both of them, okay? And we're finding the limit as x approaches negative infinity and infinity, okay? So we're going to do a similar process to what we've done before, okay? In order to, since your numerator and denominator both go to infinity, what I'm going to do is divide both the numerator and denominator by the same value. And use red to be consistent here. And we're going to divide the numerator and denominator by x. But with this denominator here, since it's a square root, we can divide by square root of x squared, because as you know, the square root of x squared would be x, right? So let's continue simplifying. The x divided by x is 1. And then if we put both these terms over x squared, you're going to get, yes, the square root of 1 minus 1 over x. Okay, now what? What happens to this limit? What I forgot to mention also, since we're going to negative infinity, any negative x value, so with that being negative, any negative x value is going to be positive. And that's not the case if we're dividing by x, right? So what we need to do is include a negative x squared right there. So you're dividing by negative, so therefore that's going to be negative on the bottom. So when we go to negative infinity, this will end up being negative 1 over the square root of 1, right? Because this is going to go, this right here is going to get closer and closer to 0 as you go to negative infinity. And so it's going to be square root of 1. And there's a negative in front, so 1 divided by square root of 1. So this limit right here will be equal to negative 1. And over here, same story, divide by x. Divide by the square root of x squared. And then we're going to get 1 over square root of 1 minus 1 over x. And then as you go to infinity, it'll be 1 over 1, which is just equal to 1. So you have two horizontal estimates, negative 1 and 1, with this given function. If you actually put this in your graphing calculator, it's actually kind of a cool looking graph. The ones with two asymptotes have kind of an interesting look to it, but they do in fact have two asymptotes. When it goes to negative infinity, it does one thing. When it goes to positive infinity, it does the other. So when we have infinite limits with a rational function, the power is higher in the numerator, it's going to go to one of two things, negative infinity or infinity. And we need to do something real quick in order to tell which one's which, right? And we have to use long division. I'm sorry. I know this may not be your favorite, but when we do long division, what times x equals 3x squared is 3x, 6x, not 6x, excuse me, 3x squared plus 6x give you negative 11x. So function left over, you do it one more time, negative 11x times x gets you negative 11x minus 22, giving you negative 22. So minus 22 over x plus 2 would be your new function, how you would rewrite this. Now, what do we know about, I don't want to do that. What do we know about this function in this rewritten way as we go to infinity? Well, this by itself goes to 0, as you know by the rule we stated previously in this video, right? Anytime we have the power higher in the denominator, this goes to 0. This, on the other hand, goes to infinity, right? Because as x increases, as you know, this is a positive slope. As x increases, the output increases. So therefore, when it goes to infinity, your answer is infinity, right? For this new function, the limit as x approaches infinity of 3x minus 11 minus 22 over x plus 2, right? As that goes to infinity, your answer is also infinity. this one right here. As you go to negative infinity, with positive slopes, as you decrease your x value, your output also decreases. So your answer will be negative infinity. I appreciate you watching, and we'll see you in class. Bye.